Okay, thank you. Thank you for the invitation to this event here. I've already seen a lot of things from the previous speakers. That's a blueprint, a lot of things that I can take along. Now, I'd like to come down from the higher levels. We've looked at Lower Saxony, we've looked at the factory, and like the previous speaker, I'll go down even lower. We'll go down to one source of energy, that is condensed air. Some people might say, well, why should I have to think about condensed air? You've always got condensed air, and that's what it's about. You've got condensed air in all buildings. All mechanical engineering companies have condensed air. They have adapters on the wall. You just plug in, and you've got your pneumatic air. You've got that source of energy. Now, something a lot of people don't know is that pneumatic air is generated by compressors, and the compressor uses electricity. In other words, if you save condensed air, you save some electricity at the end of the day. Now, why should I do this? Well, there are many reasons. I took along three here for you. One is climate protection. That's what we're talking about here, sustainability. And we saw that climate change is happening not just in Asia and in Africa. We're seeing it in Germany too. And in eastern Germany, the summers are much too dry. Let's look back to 2021. Remember the Ahr Valley? There was too much water within 24 hours, and there was a big flood there. And so we see in Germany that we've also got to deal with this quite intensively, this subject. And then the second subject, why do I have to look at condensed air? Well, if you look at your machines, all your machinery that's been installed, you have to look to see if you've got any leaks. And if there are leaks, well, that might lead to machinery downtime. So you wouldn't have your machines available. And this too is a subject which for mechanical engineering companies or users of a machine, well, it's something that you ought to look at. And as the previous speaker just said, well, energy prices, they went up dramatically last year. We're seeing that they're going back down this year, but I don't think they'll be down to the level they were at 2 years ago. But it's like with cars, people have to get away from ICE engines, but for that, diesel and gasoline or petrol have to be much more expensive. It's the same with electricity, but it's an important subject in manufacturing. Well, if companies use a lot of electricity, they do have a problem here. So you've got to give some thought to how you can reduce your consumption of compressed air. And for that, you've got to have some readings, some measurements, because you can't just have a gut feeling when you look at a machine and say, okay, let's see what's going on there. That definitely is not the right way to do things. So I have to think about where I should begin. And it could be a simple continuous improvement process. We saw that. You begin by recording. You have to look at where you are, what your status is today. And if I've got these readings, and you have the readings from a machine for, let's say, 1 or 2 weeks, then you begin to analyze. You can say, oh, look at that. Last weekend, why did we have consumption of compressed air even though production was down? And then you think about a measure, you implement the measure, and then you validate afterward, a week or two later, what the results are. You don't take 10 measures at once, because then you don't know what was good, what was bad at the end of the day. So there's a simple way to do this. Look at consumption of compressed air, and you can then check about your machine, your production system. And then you can break this down. You can say, I've got two important parts. The first important part is digitization. Digitization is an enabler. It helps me make sure that my machine, my production, well, is understood, and then have it run efficiently at the end of the day. And we, SMC, offer three possibilities here. You can begin here, you can just integrate a simple sensor. We heard about that already. We're talking about just a couple €100 here. And then you can get a ready-made system, X as a service, you can buy that, or you could even have an overall solution end-to-end. You don't just monitor things, you also can do control. Now let's go into some depth here. We'll begin with the sensor. The simplest possibility is you just take a sensor throughput sensor and put it somewhere in your line, in your circular line, to see how much you consume in your machine. You can put it into a packaging machine or other machines. Quite often, it's simpler here to use it in a NOI machine. The mechanical engineer can use that in his control system and integrate the sensor in his new machine, and then you have your consumption that's displayed to you there right at the machine. Now, if you're a manufacturer, you might say, oh, I've got a machine over here. These machines are 5, 10, 15 years old. What am I going to do with them? Well, there are possibilities here too. You can get an overall package for this. You have energy monitoring system. This is what we SMC offer. We offer a system like this so that you can look at your energy consumption. Let's say you've got a small ready-made unit that's mobile. You can put it on machine A for 4 weeks, on machine B for 4 weeks, and then you can record what your consumption is so that you can do your initial analyses. And the point here is, well, we use quite simple technology. We put a SIM card in here. The data is sent, transmitted via a simple network up into the cloud. There's a cloud solution for this, and there you have your analysis. This is not yet AI, though. Why? Because, as we've seen, many of our customers aren't yet even doing monitoring, so they don't even understand things yet. They don't even know what that machine over there consumes. So first of all, we've got to take a small step, a baby step, and then first of all, we've got to understand the consumption before we move on to the analytical tools. So that's one possibility, to use a mobile solution. Then, as of last year, we've got a new module that we call an air management system. So if you look at a machine, well, you see a pipe coming down from the ceiling, and you always have a maintenance unit at the beginning where the compressed air goes in. You can block that off if you need to. We call it an air management system. So you've got like a central unit here, and it makes it possible for you to intelligently record and monitor your data. And it has used the normal standards, OPC UA. You can transfer your data to an energy management system. So in your energy management system, you don't just have photovoltaics, gas, and energy. You have compressed air for an entire production line in there too. So you can put that data in there, monitor it, and you can control the system too. Controlling in that if you understand your machine, well, a machine can be in different conditions. We have three different ones. It's either producing or it's in standby. Standby, that might be that the packaging machine is just waiting for parts, waiting for cartons or cardboard, or the machine is in standby because it's been switched off. Now, if the machine is producing, here you have some numbers. It could be that they're producing using 1,800 liters per minute of compressed air, and the supply is at 5 bars. Now the packaging machine is, okay, it's filling in toothpaste tubes, and it's working. Now suddenly you don't have the toothpaste because the machine that's upstream is down. So what happens then? The packaging machine is in automatic mode, but it'll go into standby. So the compressed air consumption will go down, and that means it'll be down to 200 liters, even though it's not producing. It's still using that. Now you can think about that in terms of efficiency, but there are nozzles in the machine, and there's leakage too at the end of the day, and you will always lose some compressed air. As I said, 20% leakage in older machines is not a rarity. Now our air management system would recognize this condition, and it will do this. It will lower the pressure. So our supply pressure will go from 5 bars down to, let's say, 2 bars. And that means all of your cylinders will stay in their position, all of your grippers will stay where they are. If you then go and reduce your supply pressure, automatically your flow will go down. So in your machine, which is also still at a standstill, you have less consumption. it goes down by half. And as a company, you don't want to just reduce your energy, because what does a manufacturer want? They want to produce a lot and to do so efficiently. So you have to think about when you can go and try to reduce your energy consumption. And in standby times, when the machine isn't working, on a weekend and so on, there you can go and reduce your pressure level or remove it altogether. And whether you believe it or not, I know a lot of companies which do not switch off their companies on the weekend, even though they don't produce. Automotive companies leave the machines on over Christmas vacation. The robots are there. The lights are on. This, what I'm talking about, is not a rarity. So as you can see, in terms of digitization and the technology, there are ways of saying, okay, what can I record here? What can I check? What can I analyze and then control appropriately? And then there's a second thing. We can use artificial intelligence, but I think that not all intelligence has to be artificial. We've got enough human intelligence. We've got enough maintenance personnel. And each and every day they're working on these machines. I can just give you some examples. And I should have some pictures for this. You can find leakage just using your senses. You don't have to go around with ultrasound devices. You can hear leakage. You can see and feel leakage. Now, you can't do that if there's a protective fence around the machine, but listen here. You hear the noises around here. And you also see traces like this on the machine. You can see that there must be leakage going on there. You can put a label on it there, and then next time you have planned maintenance, you can go and remove that, then fix it. And maybe that'll save you 100 or 200 euros of energy costs per year just by going over and fixing small things like this. And these are small things. These are the low-hanging fruits. These are the small things that each of us could do each and every day for sustainability, to cut costs, to save energy. Now, of course, you can plan and set up a wonderful new factory, and there are experts that should be around for that. But if there are existing production facilities, you should keep your production quality up. You want to have high availability, sustainability, cost reduction, and each and every small change helps. Every 10 liters or 100 liters of consumption of compressed air you reduce saves money. Because what's the worst thing? Well, if you leave things the way they've always been and just hope for change, as Albert Einstein once said, that won't work out. The purest form of insanity is to leave everything as is and hope at the same time that something will change. Okay, ladies and gentlemen, SMC Corporation has 21,000 employees worldwide. We're global leaders for compressed air. We're the experts for compressed air. Come and see us, and we are in Hall 7 here, stand or booth C38, and I'm available for questions if you have any now. Thank you.